Hello everybody and welcome back. Root Beer here, looking at more of the 2007 Grade 8 Gauss contest. Question 19 is what we're looking at in this video. In the diagram, W, X, Y, and Z represent numbers in the intervals indicated. So W is somewhere between 0 and 0.5. X is, I'd guess X is probably something like 0.9. It's between 0.5 and 1. Y over here is between 1 and 1.5, and Z, I'd guess, is probably something like 1.7. Just based off the number line we've got here. So we got these numbers in the intervals. Which fraction represents the largest value? Okay, and I have just covered up. There we go. So we've got X over W, Y over X, Y over W, Z over X, Z over W. Okay. So this is a question where we don't actually know the numbers, but we roughly know where they are. Some things I can note. These numbers are all positive, so we don't have to worry about negative numbers or anything like that. Sometimes that comes into play with questions. So we're just looking at numbers, and all of our fractions, well, all of our answers are fractions. So we're just taking a number and dividing it by another number. So how do we make fractions as big as possible? And this is an important thing to think about. Okay, and that's what we really need in order to answer this question here. So to make a fraction as big as possible, I've got something over something. We want to make the numerator as large as possible, and we want to make the denominator as small as possible. Okay, think about it this way. If I had the numbers 1, 2, and 3, and I wanted to make the biggest fraction, well, there's only so many fractions we can make. We can have 1/3. You can have 1/2, you can have 2 over 1, 2 over 3, 3 over 1, 3 over 2. The biggest one is 3 over 1. Take the biggest number, divide it into the smallest subgroups, and you'll have the largest fraction possible. Similarly, if I wanted to make the smallest thing possible, I would pick the smallest number on top and pick the largest number to put that on the bottom. Okay? So some general theory of fractions can help us. Another thing we could do is just pick numbers, say that X is 0.9, and just do some guesswork that way. But if we understand how fractions work, how does the numerator affect how big the result is? How does the denominator affect things? We know that to make the largest possible fraction, we're going to choose the largest of the numbers possible, which I believe was Z. I think that was to the right. And we're going to divide it by the smallest number, the number closest to 0, which was W. So I would expect the answer here to be Z over W. We'll just double check. Z is the biggest, W is the smallest, so we should be looking for Z over W. Is that one of the answers? If it's not, that's okay. We could try something like Y over W, or Z over X, that sort of thing. Although, of those two, which one's the biggest, it would be harder to say. But Z over W is one of the answers, so we don't have to worry about it. E. And we didn't do any calculations there. We just sort of thought our way through the question. So that's a nice, good, decent math theory question. I like it. And we're going to finish off Part B with our next question, question number 20, and then we'll be jumping right into Part C. So I will see you guys next time for question 20.